Hello everyone, this is Heading Tian. In this lecture, we will learn chapter 5.5, Graph of Sine and Cosine Function. In previous lecture, we have learned the unit circle. The unit circle is just a tool to help us to find the trig functions. But unit circle is not the graph of sine, cosine, or tangent, cotangent. How to graph the sine and cosine function? We can use the special points and then we plot it in the xy axis. So here is the y equals sine x, and then we know that x equals 0, sine x is 0 by unit circle. And we know that x equals pi over 6, y's value, or I say sine x value equals 1/2. So plot all of these points in the xy plane. We will find this kind of graph. And then we line them up, we got this kind of shape. So this shape is sine x, and because the period of sine x is 2 pi, so from 0 to 2 pi, the x value from 0 to 2 pi, it has this kind of shape. After 2 pi, this pattern start again. That means it going up, going down, going down, going up, and then the pattern before this, it's still the same like that. And there are 5 important points on one full cycle. The first one is the starting point, is here. The second one on the sine x is the maximum point. Then the x-intercept, that means the y value is 0 because it's matching the value of y is 0. Next point, x equals 3 pi over 2 is the minimum value. That's -1. Next point is 2 pi. That's the x-intercept. So if I have a function x, sine x, and I know the period is 2 pi, and I know the shape of sine x is kind of like this. That means I can divide this one full circle into 4 parts. So 4 equal parts. This is one part, one part, one part, one part. So the value here, 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 and here, these 5 points, x values are very important to know. So the first important one is x equals 0. And second is here is pi over 2. Why? Do I have some specific way to memorize the second point too? Because we divided into 4 equal parts. So I can divide the period into 4 parts. That means I use 1/4 times 2 pi. I got pi over 2. That means from the starting points here, I add 1 pi over 2 I got here, and then from this point I add another I added pi over 2 I got here. So the next point for x value is this value plus pi over 2, that's pi. And then from here continue add pi over 2, that's 3 pi over 2. And from here I add pi over 2, that's 2 pi. Then I have all my x value. How about y's value? Y's value here is 0 because y is 0 here. How about this point? This point is 1. The maximum value is 1. How about the pi? Here is 0. And this point here is minimum. That's -1. And the last point, final point in one full circle, that's 0. And then on the graph, I can plot them. First point, second point, that's pi over 2. The maximum value is 1. And then pi, the point is here. Next point is 3 pi over 2. And that's the minimum, is here. And next point is 2 pi. The point is here. So let's line them up. I have 5 points here. I get this shape of a sine of x in one circle. Next one, let's see the cosine x. We have these many specific points, and then we plot them in the xy coordinate plane in one period. That means from 0 to 2 pi, because we know that the cosine period is 0. Oh, sorry. The period for cosine is 2 pi. And the shape of cosine is like this. So from here, going down, that's decreasing. When I got here, that's the minimum, and I go up to the maximum point. And then after that, the pattern continues. And after this, continues. And before this, it's the same. And then continued. That means the shape of the cosine x in one full cycle looks like this. And there are 5 important points, like the sine. The first point is starting point. That's the maximum point. The second is x-intercept, and then minimum, then x-intercept, and then maximum. So in this shape, we also can divide it into 4 parts. So totally 4 parts. Actually, we don't need to have the last one. So this is one part, one part, one part, one part. And we know this one is 2 pi. That's one period. So 2 pi over 4 equals pi over 2. So this is 0. This is pi over 2. This one is pi, because this one, pi over 2 plus pi over 2, is pi. And from pi, add half pi. That's 3 pi over 2. So if I have these 5 important points, 5 important x value, and then we know y value, so we can plot them and line them up. And very important things that from the sine and cosine values graph, you're gonna see the domain for the sine of x is from -infinity to infinity. This is -infinity. This is infinity. That means all x value for which the function is defined. So any point on the x-axis, I can choose any of this. So all of these values will make the sine of x defined. That means I can choose any value from the x-axis. The range of the function is the set of all values that the function make. That means, you see, the graph is bounced by 1 and -1, and -1 and 1, they are included. That means I can choose all the value in the interval from -1 to 1. I can choose any y value. Remember that the 1 and -1, they are included. For the cosine function, the domain and range is the same because I can choose all value on the x-axis for x. That means the domain is -infinity to infinity. The range for the cosine x is the same as the sine x. That's -1, 1, because the y value only appeared from here to here. 1 and -1 are included. Okay, let's move on. Y equals sine x is odd. That means sine of -x equals -sine x. Cosine x is even. That means cosine -x equals cosine x. We have mentioned this before. For example, if I have sine -2x plus 3, so there is a negative sign in front of the x. And normally, we need to get rid of this negative sign. So we can factor out the -1 in the parentheses. So keep the sign, and then factor out the negative sign. That's -1 times 2x minus 3 parentheses. Remember, if you pull out the negative sign, you change the sign here. So this is -1. And we know sine is odd. That means I can pull out this negative sign. That means this one equals negative sine 2x minus 3. This is the first example. Another example, if I have a cosine -5x plus 5. How to get rid of this negative sign? I can also factor out the -1. This one equals cosine. Factor out the -1. I have 5x, change the sign here, minus 5. And then I can put it out. But remember, cosine x is even. When I want to pull out the negative sign, it's I shouldn't say that pull out the negative sign. That means cosine -x equals cosine x. So if I see this one equals cosine without the -1. So we don't need to pull out. We just make it equals the value without the -1. That's 5x minus 5. Okay, let's move on to see next part. If we plot the graph sine x and cosine x on the same xy plane, you will see the blue one is sine x, and the pink one is cosine x. The domain for both of these two functions, they are -infinity to infinity, because I can choose any x value. And the range is -1, 1, because they are bounced by 1 and -1. I can't choose any value outside, for example, here or here. The period is 2 pi. So period for both sine x and cosine x are all 2 pi. The graph of y equals sine x is symmetric with respect to the origin. What's the meaning of that? So let's see the sine x. the sine x is like this. If it's respect to the origin, that means, so I can continue to draw because this is continued function. So if respect to the origin, that means I can flip it along the x-axis. So if I flip it, so it looks like this by the x-axis. And then I flip it, I flip this red graph along the y-axis. So I just flip the red one along the y-axis. It becomes, let's use green. It becomes to like this. It overlapped with the original one. Original one is sine x. That means if you flip along the x-axis and then you flip along the y-axis, and this function or this graph overlapped by itself, so this function is symmetric respect to the origin. And how about the graph of y equals cosine x? Cosine x is symmetric with respect to the y-axis. That means if this is the cosine function, I can continue to draw. So this is y-axis. If I do, I flip the graph along the y-axis, I can get this. So that's itself. So just like this part is looking at the mirror. So that means the graph cosine x is symmetric with respect to the y-axis. And the sine x is an odd function. That means sine of negative x equals negative sine x. And cosine is an even function. Cosine negative x equals cosine x. The negative sign disappeared. The graph of sine x and cosine x differ by horizontal shift of pi over 2. So look at the sine x. The sine x is just like the cosine x, and then move to the right. And then the cosine x is the sine x move to the left to the pi over 2 unit. So the relationship here for the sine and cosine, we can conclude that sine x plus pi over 2 equals cosine x. Cosine x minus pi over 2 equals sine x. The sign here plus in the parentheses means move to the left. And the sign minus here means move to the right. So in the graph, find the sine x, the blue line. If it moved to the left, I need to plus pi over 2. And from the pink graph, that's a cosine x. If I want to move to the right in the parentheses part, I need to use x minus pi over 2. So this one, cosine become the sine x. Okay, let's move on to the graph y equals a times sine x and a I think I missed a y here. Y equals a times cosine x. A vertical stretch if a is greater than 1. A vertical shrink if absolute value of a less than 1. A reflection across x-axis if a is less than 0. What's the meaning of that? If y equals 2 times sine x, so 2 is absolute value of 2 is greater than 1. That means vertical stretch. So the original function graph of sine x for one period is like this. But if I times 2 in front of sine x, I stretched it like this. And the maximum value here become 2. The minimum value here become -2. So I stretch it vertically. If y equals 1/2 cosine x, so I know the cosine x looks like this, and 1/2, the absolute value of 1/2 is less than 1. That means the a here we call the amplitude. The amplitude is between 0 and 1. That means the vertical shrink. So the new graph is 1/2, -1/2. The graph is like this. I just shrink it. Oh, it's not done because one circle is from here to here, and this one is to here. So that's the meaning of the a in front of the sine and cosine x. Reflection cross the x-axis if I have negative sine x. So the original sine x is like this. The negative sine x become this. I need to flip it along the x-axis, or I say a reflection across the x-axis. Let's see the example. Y equals 3 sine x. The a is 3, is positive, so no reflection. And a is greater than 1, so stretch y's value, vertical stretch. That means range will be 3 times stretched. Next example, y equals -1/2 sine x. The a equals -1/2. It's negative, so reflection cross the x-axis. And the absolute value of a, actually, I can say the absolute value of a is less than 1. It's the same meaning, like a is greater than 0, less than 1. That means the y's value shrinked. Let's see the you can practice these two by yourself. If you have any question, you can email me or let me know during the class. Next part 3, graph y equals a times sine bx and y equals a times cosine bx. So there is a b here in front of the x. That means the b will affect the x value, because we know on the xy plane, the x means the horizontal stretch, horizontal things. So the horizontal stretch, if b is less than 1, so it's different, because before we learned if a is greater than 1, so it's vertical stretch. I stretch the graph. But b is different. If b is less than 1, and we do the horizontal stretch. So these a and b are opposite. The horizontal shrink if the absolute value of b is greater than 1. A reflection across the y-axis if b is less than 0. So we just flip the graph along the y-axis. So if we flip the sine of x, if I have sine negative x, we can reflect it along the y-axis. That means like this. Okay, let's move on to see the example. Y equals sine 2x. Decide the b. B equals 2 because the number in front of the x is positive. So no reflection, and b is greater than 1, so shrink x value. Next one, y equals negative cosine negative 1/2 x. So when I see this, I'd like to make it into positive things by the function of cosine x is the even function. So this one equals negative cosine. So I just take it away. That's 1/2 x. So this one is much better, looks better. The absolute value of b is greater than 0 and less than 1. That means stretch x value because it's 1/2. Do not forget a. A is negative 1. So in front of the cosine, that's the a's value, that's negative 1. So reflection across the x-axis. So I have the graph like, oh, this is cosine. So the cosine graph is like this, for example. So I need to flip it. Okay, let's move on to next part. For y equals a times sine bx and y equals a times cosine bx, and b is greater than 0, the amplitude and the period are amplitude equals a and period is 2 pi over b. So that means if I have a question, there is a b less than 0. So by the even and odd function, I need to convert the b to the positive. For example, if I have sine x or sine negative 2x, if I want to graph it or do something, I must convert it to negative sine 2x. And then we find the a and the b. If I have a cosine 2x, oh sorry, negative 2x minus 2, so factor out the negative 1 cosine, negative 1 times 2x, change the sign, plus 2. And then this one, I can cross it out about cosine 2x plus 2. Okay, period equals 2 pi over b. So in these two examples, so the b, the new b here is 2. So the period for 2 pi over b is 2 pi over 2, that's pi. And for this one, we convert it to this function, new function. So the b here is 2. The period is 2 pi over 2, that's pi. Let's see the example. Given the function f of x equals 2 times sine 3x, what is the a, what is the b? A equals 4, b equals 3. Amplitude is the absolute value of a equals 4, and the period equals 2 pi over b. That's 2 pi over 3. And graph the function. How to graph? We need to find the 5 important or 5 key points. So I have learned that this is a sine function. The sine function in your mind, you must memorize the shape. It looks like this in one full period. That means the shape of this function must looks like this kind of a graph. I mean the graph. So let's find the first point. So I can list the x, y's value here. So for my x, the first point is 0 because the graph starts from here. And then next point. What is the next point? I mean here. Remember, we mentioned about I can divide the period into 4 equal parts. That means I use 1/4 times 2 pi over 3. That's pi over 6. So from 0, I add pi over 6, I got pi over 6. After that, I add over pi over 6 on this one, I got 2 pi over 6, that's pi over 3. Pi over 3 plus pi over 6, that's pi over 2. And pi over 2 plus pi over 6 is 2 pi over 3. And then each of them, they need to have y's value. I just put y here. Actually, you can plug in the x value in this expression, or you just think that since this is vertical stretched function, so before the maximum value and the maximum value is 1, but for this is 4 times of 1. That means the maximum value here is 4. And the minimum value is 4. Oh, sorry, -4. That means it's all clear. We know all the points. So for the first point, this is 0. And then the maximum value, y's value is 4. And then this point is 0. And then this point is minimum value is 4. And then this one is 0. So we have all of these 5 points, and then we can graph it. 0 is here. And next point is pi over 6 and 4. Next point is pi over 3 is 0. Next point is pi over 2, that's -4. Next one is 2 pi over 3 is 0. And then we line them up. We got this graph. You can also read my explanation on the notes here. Okay, well, this graph told you that divide the full interval 1 cycle into 4 parts, and each part from 0 we add pi over 6. From pi over 6 we add another pi over 6, or I say 2 times pi over 6. This is 3 times pi over 6. This is 4 times pi over 6. And then find the y value. And then line them up, you will get to the function. Let's see this one. You need to practice this. First, what is the A? A is -2. What is B? B is 1/2. And amplitude is the amplitude equals the absolute value of A, that's 2. And the period equals 2 pi over B. That's 4 pi. And then we need to plot the point. Before we plot the point, let's see, what's this? This is cosine. So in your mind, you must appear a kind of graph. It looks like this. This is one period. From here to here, it looks like this. And then it has the reflection. So the new graph will be like this. So we need to find the 5 important points. And next step, I'd like to divide the period into 4 parts. That's 1/4 times 4 pi equals pi. So here is 0, here is pi. And this one is 2 pi. This one is 3 pi. And the end point is 4 pi. So next step, I draw the graph. I know I need to plot the x-y value. The x, the first point is 0. Second point is 0 plus pi is pi. And then add another pi is 2 pi. Add another pi, 3 pi. And 4 pi. The y value, the first one must be the minimum value. Minimum value for this one is -2 because the amplitude is 2, and this is here is -2, and maximum value is 2. So this is -2, and the pi here is 0, and this one is 2, and then 0, then is -2. So I can plot it 0, pi, 2 pi, 3 pi, 4 pi, and -2, 0, 2, 0, -2. So line them up. So I got this graph. If you want to continue to draw, you can also draw like this. It doesn't matter. Okay, let's go to see next part. Graph y equals 8 times sine